Hello, everyone. Welcome to my talk, which has the title Peak Performance with Partytown, Tackling Third-Party Challenges in Big Enterprises. It's called a case study. I rather made a tale out of it, so bear with me. Once upon a time, there was a poor app, and it suffered from bad performance. So it went to the doctor, obviously. When you suffer from something, you go to the doctor to get it fixed. The diagnosis: too much third-party software. And I give you a slight warning here. Some of the following images are graphic in nature and might be disturbing to some of the viewers, and especially to our viewers here. So let me share some really, really bad flame charts. Start with the good-looking ones. So you see here a lot of tracking events going on. You see a cookie banner executing, recapture, and everything is going on the main thread, right? So the important stuff that you actually want to execute is not happening because it's blocked by tracking. Another nice screenshot, which is just full of tracking events, and you see a lot of long tasks are generated. Also, your network thread will be overwhelmed by the amount of tracking events, depending on how much you integrate into your application. Another beautiful example with like a 3-second long task, which is full of different tracking events going on. Navigation tracking, like it blocks users to move from A to point B because, yeah, you want to track the navigation, what the user does, right? Also, again, network requests blocking other resources from being downloaded. And this beautiful picture just shows a 1.3-second long task blocking your main thread. So let's talk a little bit about third parties in general. There are a lot of them. You can categorize them in ads, analytics, libraries, CDNs, customer success, hosting, social, tag managers, and tag managers are the worst of everything, and I want to talk a little bit about them in detail. Or video and utility third parties, right? So there are a bunch of them. None of the third parties are like the other. Each and every company has them. You can integrate whatever you want on your page, and if you have a big customer-facing app, you probably want to integrate all of them because you are tracking each and every move users are doing on your page. Let's talk about some numbers. So 94% of all mobile web pages use at least one third party. In the top 1,000 of all mobile pages, you see they have 43 different third-party domains running. This is crazy. And looking at the whole web, you have at least 21 different third parties going on. In total, 45% of all requests in the whole web are made up of third-party requests. And of those 45%, 34% are scripts, and scripts are the worst part of it. Meaning you have around 17% of all the web traffic is just third-party scripts being downloaded to your app. Third parties come with a performance impact. You've seen it in the beginning in the screenshots. Let's talk about some things. So first of all, third party competes with your first party on the main thread. In most of the cases, it's business need and you cannot really opt out, so you have to stick with them. And also you have like little to no chances to improve their performance. It's like their scripts, you cannot control it. They ship whatever they want and they do whatever they want on your page. And ultimately, what suffers the most of that is INP. So users have like bad responsive applications. And one of the worst of all is the Google Tag Manager. Not that I hate it personally, but it enables people to introduce Bing or Twitter or Google Ads or Meta or Amazon tracking or Snapchat, and you have really no idea what's going on. Probably it's even a different department that's configuring it, and you as a developer, you have like absolutely no idea what the marketing team is again adding to your app, but you have to deal with it and you have to improve its performance. So what does GTM do behind the scenes? It has this magical array, which is called data layer, which is just a global property on the window, on the global scope, and it monkey patches the push method. So whenever someone calls datalayer.push, you can push events directly to GTM. So this is how you essentially use it. Let's do a quick live demo on an application which has probably a couple of million users, a couple of million active sessions per day. without any optimizations, and how it looks like when there are a lot of third parties going on executed via GTM. I hope I can just, I need to stop this and I switch to the incognito tab. Yes, perfect. So I have bwin right now open. I can also refresh it so that I don't, so that you don't think I'm cheating you, refreshing the app quickly. And what I want to do now is create just a little performance profile and we see how it goes. Starting the profile with the profile initialize, very good. And now I'm just executing a couple of scripts here. Like I'm clicking around the app, navigating a bit, stop the profile, and then we can take a look at what's going on. I might want to zoom in here. And you see already this huge yellow wall that is going on here. And guess what? What you find here, even directly on the click event listener, you see here sb.push. Where does it come from? It's Google Tag Manager. So someone inside the application, inside the first party code, someone calls data layer.push, for example, or it's even yet another script that calls that. But someone does it, and even before any of the first party code can be executed, right? This is the first thing that's happening. In this case, it's just adding 50 milliseconds to our click listener. Then we have other even worse examples, this timer that is fired, and just imagine I would click here again, I would have an INP of 500 milliseconds with a ton of input delay. And guess what this is? sb.push, this is data.push, Google Tag Manager, and we see a lot of different events going on here. So we see yet another execution of this very same thing, and as we can see, here is one click listener with extremely high INP, and again, on the click listener itself, directly update data layer, and this goes to Google Tag Manager. We can also see here in the insights panel, 700 milliseconds INP, doesn't look so great. And of course, this is not our code that's executed. Someone just wants to track what I'm doing here, right? So just send some navigation events. So this is the current state we are facing. Let me stop the throttling before my CPU burns down. And we go back into presentation mode. Let me quickly introduce myself. Hey, I'm Julian, engineering manager and performance engineer at the company Pushbased. And for today, I'm your performance doctor. So let's talk about Partytown, because Partytown brings a solution to all of that problems that we have just seen. Partytown introduces something or uses something that is called the web worker. And the web worker in this story should be our helping hand. It says, don't worry, poor app, I'm going to help you out. So let's talk about technical details of web workers. We see two different scenarios here in the top. That is kind of what I've displayed quickly in live. You see third-party work is executed directly on your main thread. If you would be able to offload this work to a web worker, then it wouldn't be executed on your main thread. Thus, your INP would be better because it's a different CPU that can be used, a different core. So main thread is free, your INP is good, the work is executed somewhere else and you don't have to care about it anymore. A little bit of information about the web workers API, because we need to understand what its limitations are in order to understand how Partytown mitigates those and works with those. So first of all, a web worker can communicate with the global window and with the main thread through a messaging pipeline. So you have to asynchronously communicate back and forth. The web worker scope is self rather than window. That's also something we need to be aware of. And it has access to some primitives and constructs such as fetch and a couple of other APIs just out of the box. Limitations. It can't directly access DOM. That's impossible for a web worker because it's not running on the main thread, so it cannot access anything that lives on the window without further help. You can, though, kind of indirectly access the DOM, and this is what Partytown does. But quickly about the limitations, what would happen if you are executing, or if you want to just read document.title because you needed to attribute your analytics scripts from within the web worker? It fails because document is not defined. If you want to get element by ID in the web worker, it fails because, again, document is not defined. If you want to send a beacon, that's what analytics scripts typically do, it fails because there is no beacon. If you have something stored in your global scope in your first party on the main thread, and you want to access it in the web worker, guess what? It fails because it's just undefined. The worker has no idea about that. And this is a problem because third parties do all kinds of stuff, right? You have no idea what they're doing. They can do essentially everything. They can inject other scripts. They want to access the DOM. They can inject tag links for tracking mechanisms, stuff like that. And you actually do not want to even care about what they do. So the worker by default isn't equipped with the right tools for the job. So now talk about the Partytown solution. Partytown introduces a concept that is called a worker proxy. So on the left side, we see the worker thread. In the middle, we see yet another worker, but this time a service worker with acts as some intermediate proxy. So you can intercept HTTP requests back and forth from main thread to worker thread. So what it does is worker thread wants to read document title. Worker proxy understands, okay, I want to access something from global scope. It sends an HTTP request, which is intercepted in the service worker, which is then passed to the main thread, where you can actually read what you want to read, transform it into a message, send it back to the worker, and then you have your answer, and the worker doesn't fail. How does it do it? It uses a concept that was new to me. I didn't know that this would exist. It sends synchronous HTTP requests. So with this third parameter here, where you say false, you can actually have a synchronous HTTP request. So whatever code is executed after that cannot get executed until this request is resolved. And this is really important because if Partytown would make everything asynchronous, you would run in tons of race conditions, and you don't want that. So some visuals about that. Imagine the following situation. You have offloaded some scripts into your worker thread, and on click, you want to track that event because you just need that information for your marketing team. So yeah, you end up in the worker thread and it accesses document.title. What does Partytown do now? It sends this HTTP request. This is why you see then ProxyTown. This is how it's called. On the main thread, you actually read .title, and when the answer is finished, you have the result of .title read from the main thread via this synchronous HTTP request. And here just the most information, the most important information just highlighted. So worker sends the HTTP request, waits until it's resolved, gets the data, and can finish whatever it wants to finish. So let's integrate Partytown. Easy. You npm install the Partytown package via npm. You put Partytown.js in the head of your document. And then whatever script you want to offload, there's a special type now. So you can just declare a script type, a script tag, as type text Partytown instead of text JavaScript. And this is the trigger for Partytown to, hey, this script should now run in the worker thread. So imagine you have GTM here. If everything works fine, you see in debug mode that Partytown creates the web worker, it initialized everything, the sandbox, it registered a window environment, and so on. This is a good sign that everything works. And so the worker and the app lived happily ever after. Is what I have loved to tell you. In fact, if you just do that and you don't do further configuration, yeah, well, you end up with just a wall of errors because no third-party script is like the other. And one of the most prominent issues is CORS. Why CORS is an issue? Because when it runs on the main thread, it wasn't an issue. Now I have it in the worker, it is an issue. Why? So we need to discuss how the worker fetches scripts. This is what's happening. Typically, you have a script tag pointed to a source, browser downloads it, fine. But the worker doesn't do that. The worker actually uses the fetch API to download that script and inject it afterwards in the worker. And well, the top method doesn't require CORS headers. Using fetch does require CORS headers. So it looks like you need a reverse proxy in order to at least mimic that this script is coming from your own domain, otherwise it doesn't work. For this, there is a concept in Partytown baked in. There is a, like the reverse proxy itself, you have to build on your own, but it has a resolve URL function. So here you can determine, for example, okay, Facebook needs that CORS headers. So what can I do? I filter out for connect.facebook.net, and whenever this is, I just ask my reverse proxy to download it instead of just downloading it via the original URL. Okay, looks good, looks good. Let's try it another time and let's deploy our version to beta. Well, this happened to our tracking dashboard. So at this point here, we tried to deploy to beta, and yeah, no tracking events passing in anymore. So yeah, where's all the tracking gone? This is not how we can go to production. And then we said to ourselves, okay, it cannot be that hard, right? Yeah, one eternity later, I tell you, this was the most disgusting debugging experience in my whole life. I had to debug like manually the GTM scripts to figure out what is going on here. Until I figured out some event is missing here in this window.data layer, and I couldn't understand really what was going on until I understood some script was accessing a property called global. And what Partytown just said is, oh, you want to have global? Haha, I know its type. Here's an entire new window environment for you. So yeah, all of a sudden I had two worker environments going on and they couldn't communicate with each other anymore. Easy fix, you just give Partytown with a new script the idea of what you actually want to have as global. So this is just a custom override. I told Partytown, whenever you access global, just use the document. However, even after we did that, still events were missing, scripts were failing, because yeah, first-party script can also push events to the data layer, right? That's what I explained in the beginning, pushing stuff on this to this magical data layer array. This is how you send events to the GTM. And let's consider the following example. On the main thread, we said, say, data layer.push, and we console log it. It is actually here. On the worker, it doesn't have any idea that this is happening. For this, you also have a solution in Partytown baked in. You can just tell it which methods to forward from main thread to worker. In this case, data layer.push. And this is unique for each and every third party. So you really have to understand how they work in the background, because otherwise you cannot configure it properly. And now if we run the same example again, the worker thread actually has an idea of what is going on. You push it from the main thread and the worker thread has access to whatever we pushed. However, even after this, still events were missing. And for this, we have to consider yet another third party. In this case, it is from Bing, that is their tracking mechanism, bat.js, and they just put functions to track in global scope. UET init, UET, and so on. Those are the methods you need to use for Bing. And in the GTM.js, it asks window if this thing exists, and if it doesn't, if it exists, then it executes it. Well, in the worker, it doesn't really exist. So there's another concept, which is called global FNs. And there you just specify all of the functions that are just in global scope. Now all the third parties are here. We got more events and also more third parties, because this is what GTM does, but still errors. And now there's yet another configuration, which is called run scripts on main thread. So whenever GTM injects some script in the worker, you can just tell Partytown, okay, if you encounter this script, please just put it on the main thread, because I know it doesn't work in the worker. So yet another configuration, you can tell Partytown, I think it accepts a regex, to just, whenever you encounter the scripts where I know it fails, for example, launch darkly, then just put it on the main thread and we are good to go. So you can just opt out of it. And now, after all of this trouble and all of this configuration and manual debugging, now finally this should be it, right? So third try, let's deploy to production. The app still says, I'm not sure really what it is, but like there's something missing. Yeah, the doctor was starting to melt down because yeah, it was already such an effort, but let's take a look, okay? What is going on? We do send the tracking events, right? You see here, it's executed. But look at the URL. We are here on Hub Olympics, but the attribution for the tracking event doesn't encounter for that. It always would tell me I'm on the basic start URL. The worker has no idea about soft navigations. That's also funny. So what can you do? You can again implement some form of monkey patch. So we just give the worker in the worker scope, you see here again a script type text Partytown. So this is executed within the worker thread. Just a custom object that says PT worker location. You can name it however you want. You just need to remember the name. And we statically feed this thing here with our data from our app. So we override the location property on window within the worker to always return this object here, which we then can manually feed. Finally, we have to configure this forward again. We have seen it before, which are used for data layer.push. And then in our app code, this could be React router, this could be Angular router, it could be any kind of router. Whenever you encounter a soft navigation, you just feed from the main thread this PT worker location, which we are now forwarding with the actual location. Finally, it looks great. Our document location URL, all of our tracking events are properly attributed with all the data we need. Okay, are you feeling better now? Let's take a look at a live demo. Let me go to, yes, the actual environment where Partytown is also running. Again, I'm refreshing the page here. Again, I want to apply the same throttling as before to not trick everyone here. 6 times throttling, starting the profile, and again, I start to execute functions here. I try to do the same thing that I did before. Stop the profile. Let it process. And let's take a look at our click event. So we see click event is big, but no tracking is here anymore, right? Here's no GTM anymore. No second long timer events here on this click event. Also just first party code being executed. So where is all of our tracking? We see it here in Partytown. So here we get another lane in, let me zoom in a bit, in our worker thread. We can see here, it's also called Partytown with the nice emoji. And here we can see all of the different tracking events that were actually fired. So sp.push, that's what we have seen before. Of course, this will take now even longer than before. And the reason is, let's take a look at the network tab, if it will open for me or it won't. Yes, let's take a look at the network tab. So here we see all of those Proxytown events. So whenever we see Proxytown, the worker wanted to access the main thread. So this is the communication layer, how the worker communicates back to the main thread. So we could find here also which API was actually used, probably some cookie or the document title or whatever. Like we could figure it out now. But the gist is, now all of the work that was formerly executed on the main thread is now just offloaded away on the worker thread. Quickly stop the throttling. Go back to presentation mode. So let's talk about some real-world measurements. Also on a very similar app like this, just in a different market, to show off how huge the difference is. So yeah, we introduced Partytown in one of the applications, or actually all of those are here different products where we introduced it. And we can see just after, like in the P75 percentile, we see before Partytown INP and with Partytown INP, and we could see an immediate drop just from 1 week to the other of around 75%. And that's absolutely bonkers. Like we went from here in this app from 1.5 second INP down to 300 just by introducing Partytown and configuring it properly. So here just a simplified configuration overview of how it would look like. You just have this Partytown object that you spawn in global scope. You configure your forwards that you need, your reverse proxy, your global functions, what scripts don't work. And then you have your custom overrides in the worker, like the global property, location overrides, and whatever you would need. Of course, this requires like analysis, what's going on. But in the end, it should be possible to fix all of the issues. And if they didn't die, they're still configuring Partytown. Some pitfalls. Adding a new script via GTM always needs some developer to readjust the configuration. So in best case, you have a dynamic, so that doesn't require you to redeploy your app. Events added at the end of a session, right? So user buys something, then tracking event is for the purchase, and then user just clicks X on the browser window or closes the app in the on your phone. the worker is async and it's busy with work, the browser doesn't wait for it. So this event is just lost. It's gone, right? So that can happen. Also, for debugging purposes, you have an extremely overwhelming amount of HTTP requests going on. I've shown you this Partytown, and here just one example. I took the screenshot an hour ago. You see here 50,000 requests are going on, and all of them, like the majority of them, are just Partytown. Of course, it's not real HTTP stuff. It's just the communication layer between main thread and worker thread, but this is like annoying to see in the network tab. There are different mechanisms when you where you can opt out of the service worker, then you can communicate via atomics. But yeah, your app has to be made in order to support that. And with that, a couple of words about my company. We do web performance consulting, so feel free to reach out and when you need help, especially when you want to integrate Partytown. I'm here to help you. And this is the end. Thank you for your time. If you need something, please ping me. Here's a QR code that should link you to the slides. And with that,